last section's 5.6, and it's now that you've learned everything. You know how to add, subtract, multiply, and divide. We're going to use all those skills in solving equations. But in solving these equations, they are the same rules that we did last time. So remember, you want to isolate your variable. So you want to get your variable to one side and the numbers to the other side by doing the opposite operation, okay? So what do I mean by that? Let's look at this first one. I want z by himself. And do you guys agree that there's only one z, and he's right there, but who's in his way? The 0.8, right? We want to get the 0.8 to the other side, but since he's added, what's the opposite of adding? Subtracting. So we're going to subtract 0.8 here, but if we do it here, we got to do it right here. Okay? So remember, opposite operations will get that cancel out, right? So what's still on the left, and don't even worry about that one now, focus on this one, okay? So what's still on the left, the z, but what's 0.8, take away 0.8? Nothing, right? That's why we wanted to do it. The equal sign comes straight down, and then what's 2.5 minus 0.8? Well, we can just do the normal subtraction with borrowing. So the 5 will borrow from the 2, so he'll become a 1, and the 5 will become a 15. 15 minus 8 is 7. Bring down the decimal. And what's 1 minus 0? 1. So what is z? 1.7. And if you ever want to check it, you can add 1 point, oops, why did I put 1.17? 1.7 is our answer. And if you ever want to check it, you can say, okay, 1.7 plus 0.8 will get me to 2.5. Okay? But the key thing is you want to get your variable by itself on one side, so whatever else is over there, use the opposite operation. So look at B. We want to get x by itself, but this 0.27 is in the way. What operation is this right now when they're shoved next to each other like that? Multiplication, right? So how do you undo multiplication? What's the opposite of multiplying? Division. So we're going to take 0.27 and divide both sides by 0.27. Okay? What happens on the left side? What's a number divided by itself? 1, right? So it leaves us with x. What are we going to have to do over here? Well, let's think about the sign first. What's a negative divided by a positive? Negative. And then over here, let's do the actual math, all right? 0.27 will be on the outside, divided into 0.81. But if you recall from Tuesday's lesson, we can't actually divide by a decimal. So what do we have to do with that decimal point? But if we move it over twice here, we do it over here. So it's really 81. Okay? How many times does 27 go into 81? 3. So let's go over here and see what 27 times 3 is. 3 times 7 is 1. Carry, or 3 times 7 is 21. Put your 1, carry your 2. 3 times 2 is 6. Oh, 81 perfectly, right? So it's just 3 and we don't even have to keep going. Is that okay? So we have -3 as our answer. Guys, make sure you're following me with these notes. You can worry about that blue worksheet at the end, okay? So again, if we wanted to double check our math, we could take 0.27 times 3 and get 0.81, and we'd have the right answer there, okay? So there's our two answers. These are just getting a little bit trickier, okay? There's a little bit more steps going on. So we haven't seen multiple step equations yet, and guys, this is about the extent of it, okay? When you go on to Math 112, elementary algebra, you'll be doing a lot more, but a lot of you are pretty comfortable with algebra, okay? We want to get this x by himself, so there's two things in his way right now, the 1.5 and the 0.6, okay? Yes?
Do you follow like PEMDAS when you do it this way, or can you just do it how?
You do it how you're probably taught. What it is you want to get rid of the stuff that's furthest away from him first, okay? So this 0.6 is right on top of him. He's the last thing we're going to worry about. This 1.5 is further away, so we're going to worry about him first. So this 1.5 is added right now, so what's the opposite of adding? So I'm going to subtract 1.5 here and here. Okay? On the left-hand side, we can do that math. What's 9 take away 5? 4. Bring down the decimal. What's 3 take away 1? 2. On the right-hand side, the 1.5's cancel out, and what do we still have? 0.6x. Is that okay so far? So if you have two things that are in your way, move the thing that's furthest away first, okay? So get rid of that 1.5 by subtracting them. Now we have this 0.6 to worry about. What operation is this? Multiplication. How do you undo multiplication? Divide. So we're going to divide by the 0.6. You divide by what's in your way, okay? But if you divide him by 0.6, you got to divide him by 0.6. We got to do this math, so let's just come down here. Let's do 0.6 divided into 2.4. Because this is 2.4 divided by 0.6, so he's on the outside. And what we learned on Tuesday is we can't divide by decimals, so we got to move that decimal point over one spot here and one spot here, okay? So really, it's just how many times does 6 go into 24? 4 times. So what's this left-hand side being? Well, 2.4 divided by 0.6, we just did it. It was 4. What's our right-hand side, guys? What's 0.6 over itself? 1, and just leaves you with x. So 4 equals x, or x equals 4. What does that mean? That means that's our unknown. If we plug 4 up here and we do PEMDAS, 4 times 0.6 is 2.4. 2.4 plus 1.5 gets you to 3.9. We solved for that missing length. All right, B is like something we've never seen before because now we have x's in 2 spots, okay? So everything we've always had just x in one spot. So what we need to do is get all the x's on one side first, okay? Let that be our very first thing. So I'm going to move him over here. Does it matter which way you go? No, but I like to keep my x's positive. I don't know. So I'm going to take away 5x from this side and take them away. Like terms, guys. Think like terms, right? Who is the 5x? The only thing the 5x can go with over here? The 8x, right? What's going to happen on this left-hand side? What's 5x take away 5x? Nothing, right? That's why we did it. So what are we left with on the left side? 3.6, okay? 3.6 comes down, equals, what's 8x take away 5x? 3x. And who's still behind him? 12.9. By doing that first step, we've basically changed them into A, right? Where we, again, want to get this x by himself, but there's 2 things in our way, the 3 and the 12.9. Who do we have to get rid of first? The 12.9. Whoever's furthest away is who you get rid of first. So we want to get this x by himself, so we're going to subtract 12.9. All right. I like to say, okay, can I do 3.6 minus 12.9? No, what do I have to do? I have to flip the order and make the answer negative. So I know it's going to be negative something, but down here, let's do 12.9 minus 3.6. 9 take away 6 is 3. 12 take away 3 is 9. Does that look right? Mm-hmm. So negative 9.3 is the left-hand side. Who do we still have on the right-hand side? We haven't touched that 3x, so he's still there. But what's 12.9 take away 12.9? Nothing. And that's why we wanted to do it. We wanted to get rid of him. Okay? I still want to get this x by himself. Who's in his way? The 3. How is he in his way? By multiplication. How do you undo multiplication? Divide. So we're going to divide by 3 so he can disappear, right? But if we divide this side by 3, we have to divide this side by 3. Again, let's think about our answer. What's a negative divided by a positive? Negative. And let's just go down here. 9.3 divided by 3. Move that decimal straight up. How many times does 3 go into 9? 3 times. Bring down the 3. How many times does 3 go into 3? 1 time. So what is our answer? Negative 3.1. Isn't that crazy? So what does that mean? That means if you plug negative 3.1 into the 2 spots you see x, the left side should equal the right side. If you do 5 times negative 3.1 plus 3.6, you'll get a number. And if you do 8 times negative 3.1 plus 12.9, you'll get the same number. We found the unknown that made the left equal the right. And again, guys, you can flip-flop this order. You can write x equals negative 3.1. Okay, so C just has everything going on with it. So what's the first thing we need to get rid of? We need to get rid of those parentheses. So what was that rule? What was that property we learned to get rid of those parentheses? What do we have to do? Distribute, okay? So we're going to take this 5 times the x and this 5 times 13.7. Who's going to hang out? 6.8 minus 4x as we do it. Okay? What's 5 times x? Do you remember how we did that? It's 5x, right? It just goes in front of the variable. But I don't know what 13.7 times 5 is, so I'm going to come way down here in my scratch work area and do 137 times 5. And then I'll move my decimal at the end, right? So 137 times 5. 5 times 7 is 35. Put my 5, carry my 3. 5 times 3 is 15, plus 3 is 18, carry your 1. 5 times 1 is 5, 6, and then we move it over. So 685, does that look right? Or 68.5, because I moved it over once. And at that point, like, see, every one we do, we have one extra step, okay? So at this point, it looks like the beginning of B, okay? The beginning of B said we got to get our x's together. So I'm always going to move my smaller to my bigger, okay? So this 4x, I'm going to move him over here. But how is he over here? What is he right now? Negative. So what do I need to do? Yeah, here, say it louder. Add. So I'm going to add 4x so those cancel out, okay? But if I do it to the left, I have to do it to the right. On the left, the 4x's cancel out, but you still have the 6.8. On the right, we gathered them together. What's 5 plus 4? 9 minus 68.5. All right. Then we still want to get that x by himself, but there's two things in his way, the 9 and the negative 68.5. Who do we have to move first? You got it. It's the thing furthest away, the 68.5. He's being subtracted right now, so what's the opposite of subtracting him? Adding him. So I'm going to add 68.5. I'm going to add 68.5. I'm going to line up my decimals as I move them so I can just do the addition right there, okay? My decimals are lined up, and that's all I need in order to do addition. So 8 plus 5 is 13. Put down your 3. Bring down the decimal. Carry your 1. 1 plus 6 is 7. 7 plus 8 is 15. Put your 5. Carry 1. So do you get 75.3 there? On the right-hand side, what canceled out? What we moved, right? That's the whole point of why we moved it, is because we wanted to get rid of it. So we're left with 9x. What's your last move, guys? Divide by 9. Why? The 9's in our way because he's multiplied by x right now, okay? We want to get this x by himself, and this is multiplication, so you got to undo multiplication. I'm running out of room, okay? So our final answer is going to be positive x equals something. So down here, let's do 9 divided into 75.3. This is a big guy, okay? I know I'm kind of running, my scratch work kind of got in the way. So I'm waiting for this answer. So I'm going to do that down here, and whatever I get here, guys, is going to be my final answer. So I'll circle him. How many times is 9 going to 75? 8 times? Is that 72? So I'm going to bring my decimal straight up. And 9 goes into 75 8 times, and you get 72. 75 take away 72 is 3. Bring down your 3. 9 goes into 33 3 times, is that right? Because it'll be 27. 33 take away 27 is 6. Bring down a 0. 9 goes into that 6 times, which is 54. I know I'm running out of room, but it's okay, because notice what happens. What's 60 take away 54? 6. It is going to be repeating there. Okay? So x is going to be 8.36 repeating. Woo! I was going to add 2 more, but I don't think I need to, because I think we do. The 2 that I was going to add was something like this, where it's subtracted, but in order to do a subtraction, you just add it over, and we just did that right here. So that's it for